If you ever have doubts about the impact that construction has on the world, just take a look at the following worldwide, stunning feats that represent the amazing ability to design and build structures that defy gravity. Throughout history, bridges have been more than just crossing junctions. They are bold statements of the great intelligence and creative skill of mankind, from the awe-inspiring steel giants that defy gravity to the ancient stone pathways that have withstood centuries. The greatest bridges ever built are features of necessity and creativity. They do not just connect places, they tell stories of vision, resilience, and groundbreaking innovation. These are the top 5 greatest bridges ever constructed. First up is one of the most chaotic structures the world has ever seen, the Golden Gate Bridge. In the mid-1930s, 2 massive steel towers, weighing 22,000 tons each and stretching 227 meters into the sky, stood tall in Pennsylvania before being dismantled and shipped over 4,500 kilometers away to California, where it was to be used to build what would later become one of the most legendary bridges in history. However, like every good thing, building this bridge did not come easy, and construction logistics was just one of many problems the project would face. Even before construction began, this project faced several oppositions. From the military, who feared the bridge would make the important harbor an even more vulnerable target, the ferry companies, who claimed the bridge would steal their water transport business, or the residents who wanted to preserve their natural scenery. These concerns were quite reasonable, but the biggest obstacle was the belief that building a bridge across the Golden Gate Strait was simply an impossible feat of engineering and construction. It was not that the engineers were afraid of building the longest bridge the world was about to see at the time. It was more about the fact that the strait was notorious for hurricane-force winds, which reached a peak of 96 kilometers per hour. The weather was unpredictable and was often covered with fog. And as if that wasn't enough, it also sits on the earthquake-prone San Andreas Fault. Almost no one believed in the vision, except 3 men: engineers Joseph Strauss, Charles Ellis, and Leon Moisseiff. Strauss's original plan was a hybrid cantilever suspension bridge. He had designed a blueprint of large cantilevered sections extending from both sides of the strait, meeting in the middle with a central suspension span. This looked great on paper. However, there was one problem. It didn't work. Charles Ellis and Leo Moisseiff came along and argued for a full suspension bridge, a design better suited to handle the strait's high winds and shifting tides. Unlike cantilever bridges, which are anchored at only one end, suspension bridges hang their decks from massive steel cables. This makes them more flexible and able to withstand shifting loads, strong winds, and even earthquakes. Thanks to the new advancements in steel manufacturing, these cables could now be made from bundled wire, creating the strength needed for the longest and tallest suspension bridge ever to be built. But it was one thing to have the solution. It was another thing to implement and get resources. Getting the materials to California was a logistical nightmare. The newly built Panama Canal allowed steel components to be shipped to the West Coast, but assembling them on site was another thing. To state plainly, it was near impossible. The North Tower was built on stable ground, but the South Tower, not so much. It had to be constructed in deep, turbulent waters, and engineers couldn't drill into the ocean floor, so they used explosives to clear a foundation before pouring concrete. A massive seawall was built to protect workers from the powerful currents, and they worked in 2-minute shifts between tides. The tower was so complex that each worker carried detailed maps just to avoid getting lost. Strauss took worker safety seriously, requiring rigorous protocols for the time and installing a safety net beneath the bridge. This net saved 19 lives, workers who became known as the Halfway to Hell Club. Despite their safety efforts, the project was not without its losses. Tragically, in 1937, a scaffolding collapse sent 10 men falling to their deaths. With the towers in place, workers worked the massive cables, installed suspender ropes every 15 meters, and laid the concrete roadway. By May 1937, the Golden Gate Bridge was finally complete. There was one last decision to be made, however. What color should it be? The U.S. Navy pushed for black and yellow stripes for visibility, but architect Irving Morrow had a different idea. The bridge had been coated with a red primer during construction, and Morrow understood that this deep hue, known as international orange, blended perfectly with the surrounding hills, water, and fog. Second on the list is the Millau Viaduct. If the Golden Gate Bridge is a legend, then the Millau Viaduct is what you call a modern record breaker. And the most amazing thing is that it was built within only 3 years. The Millau Viaduct is located in southern France and is not just any bridge, it is a reflection of engineering and construction excellence. It completes a long missing link in the A75 autoroute, connecting Clermont-Ferrand to Béziers across the Massif Central, spanning over 8,000 feet and soaring higher than the Eiffel Tower. The bridge crosses the River Tarn, which runs through a spectacular gorge between two high plateaus. And for engineer Michel Verlogex, bringing this massive vision to life was the challenge of a lifetime. His biggest obstacle was figuring out how to move the bridge's 15-mile steel deck from the staging area into the open air hundreds of feet above the Tarn Valley. This vision was already massive, but the thing was, traditional methods wouldn't cut it. The team needed a way to move the bridge deck without using excessive force on the towering piers. So, they developed a solution, a state-of-the-art system known as the translator, a machine that uses polytetrafluoroethylene, PTFE, and hydraulic jacks to push the steel deck forward while minimizing stress on the structure. To support the launch, engineers built 7 temporary piers across the valley. But there was another challenge. The bridge wasn't being pushed in a straight line. Instead, the structure follows a 20-kilometer radius curve, a subtle yet crucial design feature that enhances stability and aesthetics. With its slender columns and delicate-looking stays, it almost appears as if it is floating. As the two colossal sections extended toward each other from opposite sides of the valley, GPS technology ensured absolute precision. After 15 months of painstaking work, the two halves finally met above the Tarn Valley. Next up is the Akashi Kaikyo Bridge in Japan. At almost 4 kilometers in length, the Akashi Kaikyo Bridge is one of the world's longest suspension bridges. It links the city of Kobe with Awaji Island and, as part of the Kobe-Awaji Naruto Expressway, provides onward links to the island of Shikoku. The bridge, which spans the width of the dramatic Akashi Strait, is nicknamed Pearl Bridge for its beautiful appearance. It was opened in 1998 and, after 10 years of construction, illuminated by over 1,600 lights. Surrounded by a waterway 4 kilometers wide, it is designed to withstand powerful typhoons, tsunamis, and earthquakes. Despite these immense hurdles, the project was completed on time and within budget, setting a new global benchmark for suspension bridges. The bridge is equipped with pendulum-style dampers to absorb seismic shocks, allowing it to withstand earthquakes. The 2 main towers, standing 282 meters, are built with a design that allows slight movement, reducing the impact of strong winds and seismic activity. The bridge features a network of high-tensile steel cables, each containing 29 strands of wire. The bridge deck is designed to resist wind speeds up to 286 kilometers per hour, reducing oscillation and improving stability during typhoons. Fourth on the list is the Tower Bridge in the United Kingdom. The Tower Bridge is one of London's most famous landmarks, often mistaken for London Bridge. It was constructed between 1886 and 1894 and designed to ease congestion while allowing tall ships to pass along the River Thames. Its neo-Gothic towers and innovative bascule mechanism made it a marvel of 19th century engineering. Spanning 244 meters long with 2 65-meter higher towers, the central span divides into 2 massive 1,000-ton lifting bascules, raised to a 45-degree angle to allow ships through. The bridge's neo-Gothic design was chosen to blend with the Tower of London, a request by Queen Victoria. The bridge's solid steel frame is partially visible through the windows. The bridge is fully accessible to wheelchair users and buggies, so everyone can have the opportunity to experience this masterpiece. By the late 19th century, London's expanding trade required a new crossing without obstructing river traffic. In 1886, the Prince of Wales, later King Edward VIII, laid the foundation stone, and Sir Horace Jones and Sir John Wolfe Barry designed the bridge. The construction employed 432 workers and required 11,000 tons of steel, reflecting the industrial era's ambitions. Since its completion in 1894, Tower Bridge has been an enduring symbol of London. It gained global recognition in the mid-20th century, ranking among the city's top landmarks alongside Big Ben, Trafalgar Square, and the London Eye. Last up is the Sydney Harbour Bridge in Australia. The Sydney Harbour Bridge is not just an architectural icon, but also a critical piece of Sydney's transport network. It was designed to withstand the test of time and has played a very important role in urban connectivity since its completion in 1932. The idea of a bridge across the harbour dates back to 1815, but it had major constraints to its feasibility due to a lack of technical and financial resources. However, in 1912, Australian engineer Dr. John Bradfield championed the project, proposing a steel arch bridge for its structural efficiency and cost effectiveness. In 1922, an international design competition was held. It was here that the selection of design by Dorman Long and Company took place, under the supervision of Sir Ralph Freeman. The excavation of foundations began in July 1923, with massive granite-faced pylons constructed at both ends. Accommodating 8 lanes of road traffic, 2 railway tracks, a pedestrian walkway, and cycle path, the bridge cost was around €6.25 million, which was paid off in 1988 through toll revenue. This bridge has fueled the expansion of Sydney's residential and commercial areas and boosted trade, business, and tourism. Pretty amazing when you think of it. What types of project videos do you look forward to getting next? Let us know in the comment section below. Also, please ensure you like this video, subscribe to the channel, and turn on post notifications for more videos like this in the future.